Hi everyone. In this video, we're going to look at solving quadratic inequalities. The principles we learn here can be applied to solving any polynomial inequalities and rational inequalities as well. We'll look at that in class. But if I have quadratic inequalities, what I'm dealing with is I'm using the fact that I know the sign of a product. Basically, I will know if a product is going to be positive or negative based on whether the factors are positive and negative. So let's consider this first inequality, x plus 4 times x minus 2 is less than 0. Essentially, I have a product of two things, and that product has to be negative. Now, I know that if either one of these factors is equal to 0, the product will be equal to 0. And that is going to be sort of the boundary condition here. Those are the critical values here that define intervals for me. So I have x could equal negative 4. That would give me a 0, which I don't want. And x could equal 2, which would give me a 0, which I don't want. Those numbers are not included in my solution, so I'm going to indicate that with open circles. But they do define boundaries, and on either side of these numbers, each individual factor is either going to be positive or negative. So for example, x plus 4 is equal to 0 when x equals negative 4. But it's less than 0 if x is less than negative 4, and greater than 0 if x is greater than negative 4. So any number that's less than negative 4, negative 17, for example, negative 17 plus 4 is going to be a negative number. Any number that's greater than negative 4, so 5 plus 4 is going to be a positive number. Likewise, for the factor x minus 2, it is going to be negative if x is less than 2, and positive if x is greater than 2. So now the overall product, well, if I have values of x that are less than negative 4, then I'm multiplying a negative number by a negative number, which means the product is positive. If I have values of x between negative 4 and 2, then I'm multiplying a positive number by a negative number, which means that the product is negative. And for values of x greater than 2, the product is going to be positive because we have a positive number multiplied by a positive number. I am looking for where is the product less than 0. In other words, where is it negative? So that would be in this interval. So that means that my solution is all the values of x in the interval from negative 4 to 2, non-inclusive of those boundaries. So that would be the solution set. You pick a number in there, and that inequality will be true. Now, in this next example, it's essentially the same idea, except that I don't currently have this expressed as a product. It is expressed as a sum. And that doesn't tell me anything about whether it's going to be positive or negative. So I have to start by expressing it as factors. So x plus 3 times x minus 1 is greater than 0. Now we deal with the same thing. We're looking for the boundary values, which are at negative 3 and 1. Those are the values of x that would make this equal 0. So they're not included here, but they represent boundaries between where it's positive and where it's negative. So then x plus 3 is going to be negative if x is less than negative 3, but positive if x is greater than negative 3. And x minus 1 is going to be negative if x is less than 1, and positive if x is greater than 1. So my overall product is going to be positive, and then negative, and then positive. Now, you are often going to see alternation of the signs here, but be very careful and cautious not to assume that it's always going to alternate from positive to positive, because that is not always the case. There are some exceptions. If I think about what this would look like as a graph, if I graphed y equals x squared plus 2x minus 3, graphically, I would be seeing a parabola that crosses the x-axis at negative 3 and 1. And it does something like that because it's opening upwards. So the y values are going to be above 0 on the outside edges. So here and here, in exactly the same places where the product is positive, which is actually what I'm looking for here. Where is it positive? And it would be below 0, so just to kind of here, where the parabola dips below 0, that is where the product is negative because the y values are negative. So that's the connection between the graph of this parabola and the inequality. But if you have to solve it algebraically, you're going to need to do a sign table. All right, so then that means that the solution I'm looking for is where is it positive? So x is in the interval from negative infinity to negative 3, or in the interval from 1 to infinity. Remembering that the 1 and the negative 3 are not part of the solution because I don't want it to be equal to 0. I can, however, have an inequality where I have 0 being included. So again, same idea, factor. So 3 times x squared minus 4 is less than or equal to 0, which means 3 times x plus 2 times x minus 2 is less than or equal to 0. This time the positive and negative 2, they are part of the solution, because if x is negative 2 or if x is positive 2, then this whole thing will be equal to 0, which I do want to include in my solution. So on my numbered line, I'm going to remind myself of that by using a solid circle. 3 isn't going to affect the sign of this inequality at all because 3 is positive. If I had a negative number there, then it would affect the sign, so I would have to consider it. So I have x plus 2 and x minus 2. X plus 2 is negative if x is less than negative 2, but positive if it's greater than negative 2. And x minus 2 is negative if x is less than 2, but positive if it's greater. So my overall product, positive, negative, positive. I am looking for values that are less than or equal to 0. So the negative product, which means that what I have here is x is in the interval from negative 2 to 2, but inclusive now of those boundaries. Please note that if I had had this inequality as negative 3x squared plus 12 is less than or equal to 0, we have a couple different things to consider. You have to factor it. So I start by factoring. So 3 times x squared minus 4, which is, sorry, negative 3. Negative 3 times x plus 2 times x minus 2 is less than or equal to 0. Now I do have that negative 3 there. So you can choose to keep the negative 3 there and consider it in your sign tables, or you can choose to, so let's do that here. And 2 would be if I can divide it out. But if I divide both sides of this inequality by negative 3, then I have to remember that when I divide by negative 3, I have to switch the polarity, switch the direction of the inequality. So now I am solving an inequality where x plus 2, x minus 2 is now greater than or equal to 0. So this is what happens if I divide by negative 3 on both sides of the inequality. In the first case, if I just want to keep it there, then I'm doing my sign table, negative 2, 2. I have to consider that the negative 3 is negative across this entire thing. So then because x plus 2 will be negative, positive, positive, and x minus 2 will be negative, negative, positive, my overall product is now going to be negative in the interval where x is less than or equal to negative 2, positive in the middle, and negative on the outside. So it switches the direction of my signs, so I would now be looking for these intervals.